Hey folks, I'm Mr. Hartzler. I want to talk to you about what some people call the multiplication property. Other people call it the multiplicative inverse. And I just think multiplicative inverse just sounds way cooler anyway. So that's what I call it. And let's start off with some examples. 3x equals 12. A lot of us think, okay, I need to get x by itself. And you would divide by 3. And you're not wrong. But well, actually, let me divide by 3 on this one. So x, if I divide both sides by 3, which I have to do both sides, x equals 4 in this case. But I can also multiply by the fraction version of that number. So 6x equals 18. I need to get x by itself, so I need to divide by the 6. Or I could multiply by 1/6. So by doing that, I have to do the same thing to the other side, because now the 6 and the 1/6 cancel. And then I have 18 times 1/6, which is the same still as 18 divided by 6. And that gets me 3. Off to the right, it's the same kind of situation. Multiply by 1 over 3.2. Or I could divide by 3.2, same thing. And then over to the right, same situation. X equals, and you could plug that into a calculator if you like, Desmos or graphing calculator, whatever you get, 64 times 1 over 3.2, and you should get a 20. Let's go check out some other examples here. So here's where it becomes really important, right? X divided by 4. This is actually the same thing as an x times 1/4 equals 3. So to get rid of that 1/4, I have to multiply by its multiplicative inverse. So the inverse is like an opposite of something. What undoes a 1/4? Well, that's a regular 4. And if I multiply both sides by 4, it cancels on my left, and I get an x. And 3 times 4 gets me 12. Just do the same thing over here. The multiplicative inverse, or the thing that undoes dividing by 1.2, is multiplying by 1.2. And I have to do that to both sides, otherwise my things aren't balanced, and nobody likes things that aren't balanced. And that means x equals 1.2 times 2. You can plug that into a calculator, or you can get 2.4. Now over here, this one could get a little more interesting, right? I could do this 2 different ways. I could multiply by the 2 first, then divide by 3. Or I could multiply by 3 halves multiplicative inverse. So I can multiply by 2 over 3. Cancel both of them out in one shot. So over on the left, I now have an x. On my right, I've got a couple things happening, right? When I multiply fractions, I always go straight across. That 5 is over a 1, so 1 times 3 is on bottom. 5 times 2 is on top. So I have 10/3. But let's say they don't want it in an improper fraction. Let's say I want it as a mixed fraction. Most computer programs like it like that. And to do that, how many times does 3 go into 10? So I have a 3, 3, and 3 gets me a 9. Okay. But then to get all the way up to 10, I'm one little number short. So this is actually 3 goes into 10, 3 perfect times, and I have a remainder of 1. So 3 and 1/3. And one more example, because I thought that last one was a little bit tricky too. So I'm here, I'm going to multiply by 3. Okay, and then we'll divide by the 4 later. So I multiply by 3, 3's cancel on my left. I'm left with 4x equals 18. I now have to divide by 4 on both sides. I have x equals 18 does not divide by 4 evenly. But I can simplify this a little bit. 18 over 4. I can simplify or cancel or reduce, however you want to say it, both of those things by a 2. So I'm going to divide my top by 2, and I'm going to divide my bottom by 2. 18 divided by 2 gets me 9. 4 divided by 2 gets me 2. Now, how many perfect 2's are there in a 9? Well, 2 times 4 gets me 8. So I have an 8 over 2, and then I still have 1/2 left over, right? Because 8 plus 1 gets me to that 9. So I have 4 and 1/2, because 2 goes into 9 4 times, and then there's 1/2 left over. Alrighty, so this is mixed fraction. And 9/2 is improper. And that's it, folks. I appreciate you watching. Hope you have a great rest of your day.